So just to make sure we're all clear, right? Standard is ax squared plus bx plus c. And it could equal 0, it could be y equals, it could be f of x equals, it could be any of that kind of stuff, right? That's standard. And vertex form is a and then parentheses x minus h squared plus k. Right? That's an h. And a couple things to note before we get started, right? Let's say, you notice how, like, these two things will be equal, right? Like, they're going to be the same exact equation, just written in a different form, right? The only number that's going to be the same is the a. All the other numbers are going to be different, most of the time, right? Okay, and so a couple other things real quick. You can find the vertex of this one by looking. It's the opposite of whatever that number is for the x coordinate, and then that number for the y coordinate. And this one you can find the y-intercept just by looking. I'll show you. You got confused on the vertex part, finding it, Alexa?
Yeah.
Okay.
Yeah.
We'll go over that.
The hard thing for me is the standard to vertex.
Standard to vertex is much harder, right?
Yeah.
So we'll do that one second, because this part's easy, right? So let's say we had this equation right here, 3x minus 2 squared plus 5. So you know that the vertex would be 2 comma 5, right? It's the opposite of that number, so opposite of negative 2 is 2. So 2 comma 5 is the vertex. But you can't just look and see the y-intercept, and you can't just look and find the x-intercepts, but yeah. So if we want to change this to standard form, we square first, right? You just use PEMDAS, basically, right? And you just simplify this. So f of x is going to be 3. Jose, you can't distribute first. Common mistake. You have to do the square first. So that's going to be, please don't kill a kitten. Remember? X minus 2 squared, what that really is x minus 2 times x minus 2. It's not x squared minus 4. And it's not x squared plus 4. You have to do, like, remember the shortcut? First outer, inner, last. So it's going to be x squared minus 4x plus 4. Ivan, we doing good?
You just go over that again one more time.
What, this?
Yeah. Just so.
Yeah, x squared minus 2 squared. X minus 2 squared means x minus 2 times x minus 2. You have to do, that's x squared, and then minus 2x and minus 2x, which makes negative 4x, and then these two multiply together to make positive 4. Then you distribute, right? So that's going to be 3x squared minus 12x plus 12 plus 5. And then you just combine like terms. So your final answer, 3x squared minus 12x plus 17. Vertex form, standard form. They're the same. They're the same exact equation. Their graphs would be the same. All of their properties are the same. Right. Alexa, if I understand right, you're saying if you started with this and you needed that, that's when you get in trouble?
Yeah.
Okay, we'll do that next. Ivan, you got questions about how to go from vertex to standard?
Nope, I got it.
Okay, but standard to vertex, going the other direction is tricky. Should we do the same exact one, or should we?
Yeah, let's use the same one.
Let's do the same one. Why not? You know what? It's Tuesday. It's Tuesday. Let's do this. Minus 12x más 17. Okay. This is a little tricky, but it's not impossible. You just got to be careful. What's that?
Oh, I'm saying that I actually got this problem right.
Why do you sound surprised?
Because I was just going by what I remembered.
Oh, yeah. All right, so Jose, let's do this. You ready? I'm going to try to use a couple of different colors to show you different steps, because if I did them all the same color, it would all look like the same thing. So here, I'll show you what I mean. Our first step is we take this, and I'm going to do two things at once. Are you ready, Alexa? We're going to do two things at once. Oh, yeah? Yeah? Alexa, you ready?
Wait. Okay.
We're going to do two things at once. We're going to factor this 3 out of these two things. But we're not dividing it out of everything. We're just going to, because, well, this is what we need, right? And so we're going to take the 3 out, and you're going to get x squared minus 4x. And I'm going to leave space inside the parentheses like that. Because I have to complete the square here. I have to make this a perfect square. We're still using complete the square.
So when it's vertex to standard?
Yep, let's complete the square. Standard to vertex.
Oh, standard to vertex?
What? Didn't you last class, you showed us a different way to
No,
do the standard to vertex?
no, it's just like this. I promise. It's still complete the square. This one's tricky though because the first number, is not 1.
So when it's 1, you do it a different way.
Well, kind of. You don't have to divide the 3 out. You just leave the space. Okay, but this is no big deal. So you see we're taking this 3 out of both of those numbers, and that's how we got this 3 right here. We divided it out. And you can make sure you're right because you could distribute this and get that back. So these two things are completely equal. They just look different. Okay, now you have to take half of that number, right?
Yeah.
And you have to square it. So you have to take half of -4, and you have to square it, and you have to. So I'm going to have to half of that's -2, right? Half of -4 is -2.
And then you would subtract 4, you know what I'm saying?
Well,
Like
actually
15?
12. You know why 12 is because
So on that step, you're gonna take a half of b, so you can get the
half
next
of
number.
b, and you square it, right?
Half of b, then square.
Half of b and square it, because that's like the thing about the perfect squares, right? Half of b squared is c, if it's a perfect square. And we're trying to change this into a perfect square. Ivan, this is the tricky part. This whole thing right here is inside parentheses, and it's all being multiplied by 3. We didn't really add 4. We added 3 times 4. We added 12. So I have to subtract 12. And the reason we're subtracting 12 is because we added 12 to the same side. 12 minus 12 is 0. So like if you were to distribute the 3 and then combine like terms, you would get that original equation back. Like if you
So that's -12 because it's you square the -2, which is -4.
positive 4.
Positive 4, and then you multiply that by 3.
-2 squared is 4, right? And just like he said, like it's in the parentheses, it's being multiplied by that 3, and 3 times 4 is 12. So we really added 12. But to make sure that this is equal to what we started with, we also have to subtract 12. Because 12 minus 12 is, of course, 0. So we're really adding 0, but in an ugly way. Yeah? Doing good? Okay. So that's the hard part. From here, it's easy. Now we just got to factor this, and then we're done. This is it. This is the payoff right here. This number. That's the reason why we don't square it. This one would have been easy to factor, but sometimes this is ugly. And then that's 5. There we go. There's our answer. And it is the same as the other one. So I'm 100% confident we did it right. Yeah. Hey Alexa, you have a daughter, right?
Yeah.
I have 2 daughters, and they're both out of the house now. They're both adults, right? But when they were little, you know how kids get all crazy around Christmas time? Yeah. So what I would do is I would take like empty boxes and wrap them and put their names on and put them under the tree. And then if they were misbehaving, I would burn one of those boxes.
It's so true.
It's funny. And then if they cried, I'd burn another one and tell them shut up. That's parenting right there, Alexa. Take notes. If you want to have children grow up to be serial killers, you do that kind of thing. No, of course that's not true.
What if can we do one, but when there's just a 1, when it's just
Yeah.
X one?
So you want
We like to do.
so you want standard to vertex, right?
Yeah.
But you want the A to be 1.
Yeah.
Okay, so like say we had something like, I don't know, x squared. Do you want it to be even number or odd number? Because odd is harder and even is easier.
No, odd.
Odd?
Yeah.
Oh, how rude. Like that, right?
Yeah.
Okay, so we're going to find the vertex of this. Well, no, we're going to change this to vertex form, right?
Mm-hmm.
Okay, so there's a couple little things that are different. You don't have to divide out a 3, right? But you're still going to rewrite it. X squared minus 5x. And you're going to leave space. So that's our first step right there. But we didn't have to divide out a number because that's 1. So a is 1, right? And then do you see on this one? Do you see how a was 3 in standard form and a was also 3 in vertex form? That's very important. If these would end up being different, then you did it wrong. Because like you see the generic standard form, generic vertex form, a is the only letter that's the same. These numbers have to be the same or you messed up. So this one, a is 1. So life's easy. Now we have to take half of that number, which is divide by 2, right? And we have to square it. This is now a perfect square, which is what we want. But we added it, but we only added one of them, not 3, like last time we added 3. So since we added it, we have to subtract it. But here I'm going to go ahead and square it too. So that's going to be 25 over 4. And it is subtraction. It's not like, it's true that negative squared is positive, right? That's very true. But we're adding it here and we're subtracting it there. So don't like trick yourself with those signs. That's where you would maybe mess up that. All right, we got to do a little bit of work now. We got to factor this, x minus 5 over 2 squared, and that's exactly why we don't square this, because it would be really difficult. Like, let's say it would be almost rude if you had to factor that right there. If you had to factor that, it would be hard to see that those are that would be the factors, but it is. If you do x minus 5 halves squared, you do get that back. I promise. Do you want me to show you? I'll show you. Watch, Alexa, because this is cool. Watch. Check this out. I'm going to show you that this thing squared equals that. Listo? Okay. X minus 5 over 2 times x minus 5 over 2. And this is also going to talk about Ivan's question about this a minute ago. It's going to talk about that some more. So, first two multiply together, that makes x a square. Yeah? Outside, that is minus 5 over 2x. The inside, minus 5 over 2x. The last two, negative times a negative is positive, 25 over 4. We have to add these together. Negative 5 minus 5. Isn't that negative? Isn't negative 5 minus 5 10 over 2? Isn't that true? That would be 10 over 2. 10 over 2, isn't 10 over 2 5? Yep. This thing multiplies to make that. This is the factors of this are x minus 5 over 2 squared. That's why we don't square that. There's no way I would be able to factor that. I would probably get really stuck. I'd probably think, oh, not factorable, and just move on. Okay, got to put that together. Alexa, isn't 1 4 over 4?
Yeah.
Okay, let's do it. Don't get mad at me. And that's negative 29 over 4. And there's vertex form. That one was tricky because of the fraction, but it was easy because a was 1.
Negative 4 over 4 again?
From 1? Doesn't 1 equal 4 over 4? And don't you have to get a common denominator when you're subtracting fractions? So why make it difficult? 1 is equal to 4 over 4. We need 4 for our denominator, just done. Like a math gangster. Right, Ivan? Yeah. Math
Okay,
gangster.
I have another.
About this or something else?
Yes.
A question about this or something else, Alexa?
Oh, no, I think you already said that.
Oh, okay.